Hello everyone, I am Madavan. Today I am going to present about coronavirus analysis using SQL. COVID-19 has dramatically impacted our world, highlighting the importance of data analysis in understanding and managing the crisis. Today, we will explore how SQL can uncover significant insights from COVID-19 data. By analyzing patterns and trends, we aim to provide valuable insights that can guide public health strategies and improve our response to the pandemic. Our goal is to examine the COVID-19 dataset to understand the virus spread over time and across regions. We will look for key trends in confirmed cases, deaths, and recoveries, and analyze how these numbers have changed monthly and yearly. Through statistical analysis, we will quantify the virus impact and derive insights that can inform future response strategies. The dataset includes crucial information such as geographic location, province and country or region, coordinates, latitude and longitude, and dates. It tracks confirmed cases, deaths and recoveries. These elements allows us to perform detailed analysis and draw meaningful conclusions about the pandemic spread and impact. Before analysis, we prepare the data by previewing it, choosing how to import it, selecting relevant columns and defining their attributes, and finally we finish the summary. This process ensures the data is accurately loaded and ready for analysis, setting the foundation for reliable and meaningful results. First question. We started by identifying null values in our dataset to ensure data completeness. The query checks each column for null entries. The output shows that there is no missing values. Next, we updated any null values to appropriate defaults. For example, we set missing geographical data to unknown or 0 and date entries to 1/1/2000. This step standardizes our data, making it more robust and reliable for further analysis. We then check the total number of records in dataset using count function. The output gives us as 78,386. To understand the time span of the data, we identify the earliest years and latest dates by using min and max function in date column. The output reveals these starts and end dates. We identified how many distinct months are represented in our dataset using the extract function. The output shows we have data spanning over 12 distinct months. By calculating the monthly averages for confirmed cases, deaths and recoveries, we gain insights into the typical monthly trends. The output reveals these averages, helping us to see the general pattern of the virus impact over each month. To understand common reporting patterns, we identify the most frequent values for confirmed cases, deaths and recoveries each month. The output shows us these frequent values, indicating typical figures reported monthly. We then looked at the lowest reported numbers for confirmed cases, deaths and recoveries each year. This helps identify the periods or region with minimal impact. The output shows the minimum values, highlighting the least affected periods annually, which are 0 in both the years. Conversely, we identify the highest reported numbers for confirmed cases, deaths and recoveries per year to pinpoint peak outbreak periods. The output reveals these maximum values, showing when and where the highest impacts occurred each year. To understand the overall monthly impact, we calculate the cumulative totals for confirmed cases, deaths and recoveries each month. The output provides these monthly totals, reflecting the virus' overall monthly burden. We analyze the spread of confirmed cases by looking at their total, average, variance and standard deviation. These statistics gives us a detailed picture of how consistently or variably the confirmed cases were reported. The output quantifies the overall distribution and variability. Similarly, we examined the monthly distribution of death cases using the same statistical measures. The output shows total deaths, average monthly deaths, their variance, and standard deviation, providing insights into the monthly fluctuation of fatalities. For recovered cases, we used total, average, variance, and standard deviation to analyze their spread. This gives us a clear view of how recovery data is distributed. The output highlights these statistics, showing how recoveries varied across the dataset. We identified which country had the highest cumulative number of confirmed cases by summing the cases for each region and sorting them. The output shows the US as the country with the most confirmed cases, indicating its severe impact. To find regions with better health outcomes, we identify the countries with the lowest cumulative death counts. The output lists the countries with the fewest deaths, suggesting better management or lower fatality rates. Finally, we identify the top 5 countries with the highest number of recoveries by summing the recovered cases for each region. The output lists these top countries, highlighting where recovery rates were most significant. Key findings from our analysis include confirmed cases surged early in 2020, peaking in February at 58,116. The average monthly confirmed cases were around 25,698, with high variance indicating significant fluctuations. The US had the most confirmed cases, while China excelled in recovery rates and had the lowest death count. February showed major increases in cases and recoveries, revealing different regional responses and outcomes. These findings highlight critical periods and regional impacts of the pandemic. Future research can focus on city-level data to understand local transmission dynamics, develop predictive models to forecast future outbreaks and surges, integrate data combining different kinds of COVID-19 stats with vaccination and policy data for a fuller picture, enhance visualization, creating tools to make data more accessible and actionable. These directions will improve our ability to respond to health challenges. Our analysis revealed crucial insights into the pandemic's spread and impact. We highlighted significant trends, especially in early 2020, and underscored the value of data-driven strategies in managing health crises. SQL and data analysis provide the meaningful patterns and actionable insights. Ongoing analysis is essential for monitoring COVID-19 and preparing for future challenges. Thank you.